Welcome to 1.5 Lists Part 3. So in this lesson we're going to learn about a bunch of new methods that we can use to work with lists. We're going to learn how we can work with slices and lists. And finally we're going to finish up with generators, which is a very cool way of creating lists and modifying lists. Okay, so let's jump right in. We're going to start with max and min. So when you're working with numeric lists, that is lists full of numbers, you can use max and put the list inside as a parameter. This is a function that will give you the highest value element in the list, while min gives you the lowest. So for example, let's do this over here together. Type Python. So if we have y equals 1, 2, and 3, we can type max and put y inside, and of course we'll get the highest number in the list, which is 3. And min gives us the lower. Oops, pardon me, min y, right? We put the list in there, and so that, of course, is 1. Now, if you use this with a string list, like the following, y equals a, comma, b, comma, c, right? Now, if you type max y, watch what happens. So this time, you get the highest letter in the alphabet, okay? So basically, or basically, whichever string would come last in the alphabet. So we call this alphabetical order. Right, so the max gives us the highest string in alphabetical order, whereas the min gives us the lowest string in alphabetical order. So that's kind of handy. Now next, we can also change the criteria by which these functions determine what is the max and the min. So for example, let's say we have these three strings in our list y. Then we could specify that the max we're looking for, if we type max and then put the parameter key equals len, okay, right after that, then what this means is we want the criteria to be how long the string is, right? So this will now give us the longest string, which is cattle, okay? And if we type min y and we type key equals len, then this will be the shortest string, right? So because by default, max and min for strings, of course, return the lowest and highest string in alphabetical order. But when you specify length, then it changes the parameter, right, that it uses to determine whether or not it's the longest or the shortest. So let's now look at count and sort. So if you need to know how many times an element appears in a list, you can use the count method. Now this, of course, is a method. This is not a function like max or min that you write implicitly. And what count does is it tells you how many times string x, or element x, I should say, appears in the list, right, on which you append this method. So again, here, if we have y equal to this, you can also cut and paste this with me if you like, or type it out. And we type y.count. And if we type in element 1, it's going to say 3, because there are 3 ones in the list. Right? So this is what count does. If we type y.count 2, we get, of course, 2, because there's 2 2s, and y.count 3 gives us 1, because there's 1 3. Now, if you type something that's not in the list, what do you think will happen? 0, right? There are no 4s in the list. Right? So this is kind of a shortcut to telling whether or not a certain item is in a list. If you count it and there's none, then of course you know that that item, this element, is not in the list. Now, if you want to sort a list, okay, then what you can do is use the sort method. Now, sorting, of course, means rearranging all the elements in the list from lowest to highest, or optionally in reverse. If you set the reverse optional keyword, then it will go in descending order. Okay, and so let's say here we have y equals the following, right? Dog, cat, snake, giraffe. We could type y.sort, and what this will do is sort the list for us. Now notice how this didn't print anything after we typed it, right? So this sorts it in place. This means it doesn't return a new list. This just literally sorts it. So if we type y and see the list now, you can see now it is in order. Okay, so if you want to sort a list, you just literally type this, right? And you don't have to print it because it will do the work for you and then change your list. Okay, Now we can optionally, again here, specify a keyword, and this will of course change the parameter again by to whatever you want. In this case, it could be the length of the words, right? So we could sort this not in alphabetical order, but by order of the length of the words that are there. So if we type y.sort and then we type key equals len, then now let's look. So this time now we said, hey, I want this to be sorted according to the length of the words inside the list. Right, so this is how that works. And I'll just show you how we could reverse it. Right, if we typed key equals len and we type reverse equals true, right, then when we type y, now it'll be in the opposite order because it goes from longest to shortest. So both max and min and the sort function use this key, right, this key parameter optionally. Now let's look at clear and copy. So the clear method removes all elements from a list, while copy, okay, the copy method creates a duplicate of the list. Let's use this visualizer. So click this with me. And we'll go here for a minute. And what you see is I have some examples of clear and copy. So let's click through this. We'll click forward. First, what we're going to do is set X to a new list 1, 2, 3. So you can see there in our global frame, we have the name X pointing to this list 1, 2, and 3. Now, in the next step, we're going to assign Y to the same list, right? So now Y is also pointing to this list because remember, right, this is not going to store anything in here. This is going to store a reference to this object when we do this because a list is an object. Okay, now if we use x.clear, what that's going to do, of course, is just it's going to clear the list to which x refers. So it's going to go from here and be like, oh, this one. Okay, so now that list is gone. So if we print this twice, x and y, we see the same thing, right? X and y refer to this empty list. Okay, so clear basically removes all items from a list and it becomes empty like this. Now, I want to show you how this is fundamentally different when we use copy, okay, .copy. So this time we'll set X to 1, 2, 3, okay, and, oops, pardon me, I went too far ahead here. Okay, so we'll set X to 1, 2, 3. So there it is, right? So the same list, but next time, instead of assigning Y to X, we're going to assign, instead of assigning it Y to X, we're going to assign it to a copy of X, right? So now Y will get its own object, right? And now refers to a completely different list, right? So now X still refers to the first one. So on this step, when we clear X, you'll see that one become empty, but Y still points to its own copy, right? So now when we print these, we'll see that this time, right, there we are, we have X, which was empty, and Y, which was still full because it referred to a different one. So this is the key here. If you need to make a copy of a list, right, if you want to use multiple copies, then this is the method to use. You make a copy, assign that to another variable, and that way you know you're not working with the original. Okay, let's go back and have a look at slices here. All right, slices are just like strings, right? And they're parts of lists that can be referred to using slices. So however, okay, unlike strings, lists are mutable and therefore can be assigned and changed using slices. So I just want to show you a few simple examples how this can be done. So let's say we wanted to print every other element in a list, starting with the first, and then again starting with the second. Well, remember that we can use parameters in a slice, right? So the parameters are, and it's not really shown here, but it's the start value, the stop value, and then the step value, right? So a list looks like this. It looks like start, stop, and step. Or rather, a slice does, right? So if you put this on the end of anything, then it will take part of it according to these parameters: your stop, your start, and your step value. So we can use this, and let's just assign Y to this list. Let's see, 5, 4, 3, 2, 1. There we go. And now if we type Y and we slice it, we can say we want, let's say, every other element, which would mean we include a step value of 2. Right, so this gives us 5, 3, and 1 because it skipped, right? It skipped 4 and 2. It was going by 2. Let's say we wanted to reverse the list. Well, we could just specify a step value of -1, right? And that gives us the opposite, gives us the list in reverse. Or if we wanted to start from index 1, well, we could start at 1 and at 3, right? And then we would get just part of the list again, right? So this is how you can slice a list just like a string. The last one here says to start at index 1 and go every other character, we could just specify the start value of 1 and a step value of 2, right? So in other words, if we said y1 : 2, we would get 4 and 2. So that's it for this part. You can go ahead and on Replit complete assignments 1.5a to c. And in fact, you should at this point be able to complete all the assignments on Replit. However, this next section on generators will make you very powerful with lists. So I would recommend that you follow through with this next section on generators when you're done A through C. All right, so welcome back. Generators, also known as list comprehensions, are an advanced topic, an advanced way of creating lists in Python, or modifying lists. Really just creating them, because every time you use one of these, you get a new list based on some other list or some other iterable. So I'm going to show you how this works. Now, generators allow you to create a list using a function, and they're structured as follows. So you start with your variable to which you want to assign a new list, and then in list brackets, right, because we're making a new list, you're going to include these parts. First, the function of the element, okay, and this is the thing that the output that we'd like to have for each element, and this can be based off the elements in the list defined by the variable used in the next part, or it can be something completely unrelated, such as input. And you'll see this in a moment. So you type in your function first, and then you have a for statement. And this is really just very similar to a for loop, basically the same thing. But this for loop is what tells this thing how many times to run. And so you're going to go for element, and this is your variable that you're going to use, okay, in iterable, right? So this could be a range object, it could be a list, it could be anything that has a bunch of things in it, right, that you're used to working with. So really you have your function of your element, and then you have your element. This is really just a variable name that you choose to represent the elements in the list, right? So this element is going to take, just like in any for statement that you use, it's going to take the value of every single item in this iterable one at a time, right? And then, right, this list is going to be composed of whatever function of that element we want, right? So all the items will be a function of each element in this iterable. Okay, so let's do an example, because this is kind of tough to understand on its own, and really the best way to look at this is just to play around in the terminal until you understand. So example 1 says convert a list of strings into convert a list of numbers into strings and vice versa. So one thing that we often have to do when we're taking numerical input, or we want numerical input, is convert our strings to numbers, or vice versa, right? Let's start by going numbers to strings, and then we're going to go backward. So let's say we have this in our terminal. Type j equals list range 10. Now don't forget, right, when you do this, and we'll type j, you can see that this gives us a list of all the numbers from 0 to 9. Right? You have to use this little list function to convert a range object to an actual list. And so here we have all the numbers from 0 to 9. Let's say we wanted all of these to be strings. Well, what we could do is we could use a list comprehension. Okay, and so here's how it would work. We would type, let's assign this to k, and then we'll say k equals, we'll start an open bracket for our list comprehension. And now what we want to do is, you can see it written here, but we want to convert each of these to a string. So we're going to type str, and then here, this goes, this is our element, right? This is our element variable that we want to use. And so this is going to be like x from our for loop, right? So we're going to type string of x for x in, and now we know we have our list actually already here, right? Which is j. So for x in j, Now we'll type enter. Now what this did is for every x in J, so in other words for 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, it created this list by taking the string version of that x. Right? So x became 0, 1, 2, and every time this list gave us, it was made up of all the string versions of those, right? So this converted these all to strings and gave us the new list and stored it in K. Right? We could go in the opposite direction, right? By let's say we want to make another list, and we'll call this one P. Let's say we want to make these back into integers or floats. Actually, let's do float. So we could say float x for x in, and this time we could go K, and what it will do is give us the float versions of all these things, right? Because now for every x in this K, right, it converted each element to a float, right, and made a list out of that. And that's what P contains. So, right, this is super easy, right? If you take, say you take a whole bunch of inputs, right? Like let's say you use input.split, right? And you take a whole bunch of inputs, then, which as you know, right, we're going to have, you know, like 1, 2, 3, 4, 5, right? You're going to get a list of strings, which is kind of a pain, because if you want to do any math with these, then you have to go through one at a time and convert them all to integers or floats, right? So how could we make a list of integers? Well, we could use a list comprehension, right? We could say our num list, check this out, is equal to, and here we could convert each thing to a float or to an int. We'll say an int, right? Int x for x in, and now we could type in our input dot split, right? And of course that's going to give us a list of things, right? And so we could now type in 1, 2, 3, 4, 5, 75, 76, 77, 78, and now let's type num list. And you can see we have a list of all those nums, right? Which is pretty handy. Okay, what's next? So the example 2 says use a generator to input a list of entries from the user. And so let's just do this in another way first. Okay, so what we'll type is print. And in fact, we don't really need print in the terminal, but we'll put it in anyway. Input for x in range 4. There we go. And so let's think about this for a minute. So what is this doing? Well, we're going to go for every x in range 4. Now, x is going to take the values 0, 1, 2, 3, right? And for each one, right, we're going to have a list made up of this. Now, notice how there's no x in here, right? This is literally just going to take an input 4 times and put it in a list. That's what it's going to do, right? Because we have this little for loop, essentially. So we could type here our inputs, you know, A, B, C, D, and there we go, right? There's our list of 4 letters, the 4 things that I typed. Now, what if we wanted the user to enter the number of inputs before the list, right? So let's say we don't necessarily want 4, we want the user to say how many things are coming. Well, we could do that too, right? We could just say input for x in range, and here we could type int inputs, right? And what this will do is give us, oops, I left a bracket out here. Let's add that. Okay, 3 brackets. Now we could type in the number of things that we want to input, like say 3 things, right? And now we can type what we want, right? Cat, dog, bird, and we would get those things, right? So in other words, you can actually just literally put an input right into the range object, right? And so then before this list comprehension will actually work, it gets this input first because it doesn't know how many times to run this and how many times to invoke this function, right? So that's how that works. And let's keep going. The next one here I have is the same type thing, but with a cool prompt that actually shows the entry number that we're entering, right? So let's look at this for a minute. I'm just going to take this without the print function because we don't really need that, so you guys can see it. We'll press cut and paste this. And so what do we have here? So here's our little for loop, right? So for x in range int input. So we're going to type our number in first. That's going to say how many elements we're going to have in our list, essentially. And then for each of these x's, for each of these elements, we're going to use the input function with the prompt formatted so that it's going to fill in this number here with the index of x, right, which plus 1. So the first one's going to be 0. 0 plus 1 is going to be 1. So if we press this and we type, say, 5, right, then now we're on entry 1. And this is going to go in, whatever we type here is going to go in as the first element in the list, right? So we could type some numbers, 10, 20, 30, 40, 50, for example, right? And then we have our list of 5 things. And we could even convert these. If we knew we were getting numbers, we could convert them to integers or floats by just wrapping this whole input function with a conversion, right? Int or float, and we would get this whole system would be done in one line, right? We'd have this whole list done in one line. That's what's so cool about these comprehensions. If you can figure them out, if you can wrap your head around them, they can save you a lot of time, right? So again, right, we could always still just do our int input. We can do our split int.split and include that in the function in the generator, which I showed you before. So we'll just skip this one for now. All right, example 3. Okay, so example 3 says create a list generated by a user-defined function. Okay, so what this means is, let's say that we wanted to create a list of y values for the quadratic function f of x equals x squared minus 3x plus 1. Well, actually, I'm just going to use f of x equals x squared, just a regular parabola to keep this simple. Well, first what we do is define f, right, as our function, and then we could use it right in our generator, right here. Let's type this one out together. Okay, so we'll call this list generator example 3. Okay, so we'll define function f, and we'll give it the parameter x. And then we're going to return, right? What we're going to do is return x squared. Right? We'll just keep it simple. So basically all f does is it takes the value x and it returns the square of x. Right? So now let's create our list y. So y will be equal to, and now what we can do is say f of t, and we'll use t just to keep these letters different, right? Because there can be some risk in keeping them the same. Passing these things in can be sometimes create errors if we're passing in mutable objects. So f of t for t in range, and let's do the numbers from 1 to I don't know to 5. So we have to put 6 there at the end, right? And then at the end we'll print y, and we'll see what happens from doing that. So what we should see now is a list of all the squares of the numbers from 1 to 5. There we go, right? So what this did is, right, and I'll just show you this. We'll step through, actually. That's probably the nicest thing. So if we step through this, right, as soon as we get here, it's going to invoke this list comprehension. It's going to use f 6 times, right? So here's the first one. And actually, I wanted to show you this. If you step through the list and you're on the line with a list comprehension, then what will happen is it will actually really not show you anything. So this can be a little bit confusing sometimes. And if anything, that can be the risk. But you can see here that t is going up, and it printed it again. So so anyway, this is how you could use a user-defined function within a list generator like this. All right, so let's do something completely different here. Part B says, let's say we wanted a list of choices made for different pizza toppings. So there's code for this here in this little link. So what you can do is right-click this. Of course, that's going to give you your code. Copy it and paste it in here as example 3B. All right, there we go. And comment out the first one. Okay. So what I've got here is a little function that will basically take one parameter called topping, and this is going to be basically cheese or pepperoni or mushrooms, a string with some sort of topping. And then it asks a choice. It asks, would you like to add, and then cheese or pepperoni or mushrooms, whatever topping was passed in, because we're including that here in our format function. So this takes some inputs with that prompt, and if the choice is yes, we return true, and otherwise false. Right? So this function returns true or false. Now, down below, there is a constant list of the toppings that are available for this pizza. And I've created a list of the user's choices by including this function want topping as the function in my list generator. So let's just look at this for a quick minute before we run it. This here, for option in topping list, right? This part here is what starts the loop that starts generating the entries or the elements in our list, right? So however many options there are here is how big our list will be. In other words, we want to know, do they want cheese? Do they want pepperoni? Do they want mushrooms, right? So for each of these things, right, this function will run and it will use the option in topping list, right? So it will call this function, and whatever this gives back, this will evaluate to that return value, which we know is going to be true or false. So this will give us a list, right, with true or false for each of these choices in the same order, the same size. So let's run this, and you should see that we're going to get 3 questions. Would you like to add cheese, right? So we could type yes, and pepperoni, no, and mushrooms, yes. And you can see we got true, false, true, right? So the function determined, right, it actually asked the question and then returned true if we typed yes, which then went into the first, right, for cheese, that went into the first element, right? And then for pepperoni, right, it went back here, passed in pepperoni, printed the question, and then returned false because I typed no, right? And then again, for mushrooms, that went back up here, returned true, and that became the last element in the list comprehension. So this is another way that we could use a function, a user-defined function, in a list generator. Okay, so one last thing here, question. If we wanted to add more toppings, right, topping options, what would we need to do? Well, what's really neat about this is that this list is generated based on how many options are in topping list, right? So this is going to run 3 times because there's 3 things in there for option and topping list. So if we wanted another topping, we could just type it in, right? Pineapple. And now this is going to run 4 times, and it's going to give us a true or false for pineapple, right? So let's just check this to show. Cheese, yes, 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 and there's pineapple, right? So now we got a list of size 4. So that's what's beautiful. Another little beautiful thing about this. All right, what we're going to do now is look at conditions that we can add to generators. So a condition in a generator goes here, right at the end. If condition. All this really does is it basically gives us a way to decide whether or not, okay, we want to add this element, okay, that we find. So if we come across, for example, an option here like cheese, right, and we want to decide if we want to include this in the list that we're making based on some rationale, then we can create a parameter, or sorry, a condition in here, right? And that's going to be the next topic here. So we're going to do that in a minute. But for now, let's try this. Create a list of only the negative numbers entered by a user in a sentence separated by spaces. So let's copy this here, and we'll just grab that whole part, not including the print statement, and we'll paste this into the terminal. Okay. So what this is going to do here is, first of all, for x and input.split, so we have to type in a bunch of numbers, right? So we'll type in some, including some negative numbers like -5, -3, -2, 1, 2, 1, 4, 9. There we go. All right, and so what this did, if you'll notice, is we lost all the numbers that weren't negative, and the reason is because this converted x to a float, right? Because x was each number typed in, right, in this list, input.split, converted to a float if that float was less than 0. In other words, if the float, right, was negative. So now how can we change this to only positive numbers? Well, press up. There we go. A couple times, right? Of course, that just means reversing this as long as it's greater than 0. So if we press enter, and then now at this point we type the same numbers, -5, -3, -2, 1, 4, 9, then you'll see we'll only get the positive one. So all this really does is it filters the list, it filters the new list based on some condition. So this will come in handy for some of the assignments you're doing for this section, because you could literally write them in one line with a generator if you know how to use this. Example 5 says create a vegetarian topping version of the pizza topping example. So really, we want to create a new list of vegetarian options. I've already got the code done for you here. So again, you can click this, copy this, and paste this in. And we're just going to kind of overwrite the last one here. And what you'll see is I've added this vegetarian list, which is a separate list. And I've added a condition here at the end to filter, all the choices that we'll be making. So let's just close this for a minute here so we can see the full thing. And we'll close that. All right, and so this vegetarian list has cheese and mushrooms, because of course pepperoni is not a vegetarian option. And topping choices now will be made up of want topping, right? This is the function that returns true or false if we say returns true if we type yes for each option in topping list if the option is in vegetarian list, right? So in other words, we're going to go through all the options in topping list one at a time, but we're only going to call this function and ask it if that option is in vegetarian list, right? So this is only going to now work for cheese and mushrooms. Let's just give this a try and see that this is true. Would you like to add cheese? Yes. Mushrooms? No. And we're done, right? So essentially this little list here that we created was great because we could use this in our condition. You can have any condition you want here, right? You can be creative. You can there's no limit to how this can be used, and it's very powerful. Okay, we're going to do one last thing here before we move on, and that's add a function condition. So there's one last thing you can do with the generator, and that's you can have a condition here, okay, in the first part, right? And what this will let you do is put a little if-else statement inside the function. And so let's say that you want to use a certain function if something is true, otherwise a different function, okay, for all the elements in the list, right? So, for example, all right, let's create a generator that populates a list full of the strings even or odd corresponding to each number in a given list. So what this will do here, if we just type this out, let's create one last example. We'll call this example 5, function conditions. And okay, so we'll comment these guys out here. There we go. And we'll take this out. So we're going to import random, first of all. And then we're going to say numList. Oops. NumList equals random.randInts 1,20 for x in range 5. Okay. So what does this do? Well, what this does is, well, for 5 items, for 5 times, what we're going to do is create a list of random numbers between 1 and 20. Right? That's what this should do. So when this is done, numList will contain 5 random numbers between 1 and 20. Now, let's print this. So say print numList, and now we should see that. Let's run the program. Here we go. 9, 14, 12, 3, 13. So now let's create an even odd list. And this is going to contain either odd or even, depending on whether or not each of these numbers are odd or even. So this is the perfect opportunity to use an if-else, a function condition. So what we want to do is add the word even, right? If, and now we need a variable. We can just call this x, right? We'll use x as our elements that will cycle through in numList. So if x, of course, modulus in this case, which is 2, is equal to 0, else odd, right? And so in other words, we're gonna put even as our element if x is even, else odd, right, for x in numList. Okay, and then we'll print even odd right there. All right, so let's run this and see if this works. All right, so this time we got odd, even. Of course, 1 is odd, 7 is odd, 4 is even. So you can see that that worked beautifully, right? And so it went through each item in numList, right? X became 19, 20, 1, 7, 4. And each time it checked if it was an even number and it wrote odd if it wasn't, or even if it was. And that's how you can add a function condition to a list. Just one example of many options. All right, so go ahead and create or complete Replit 1.5 assignments D to G. And when you're done that, you can start project 3. Good luck.